the local behavior of the function, the reciprocal function 1 over x. So we're going to begin by looking at the reciprocal function. Now recall that we cannot divide by 0, which means that the function is undefined at x equals 0. So 0 is not in a domain. As the input values approach 0 from the left. So what it's saying here is that if I have think about the x-axis, okay? And so here is R0. And what it's saying here is that as x is approaching 0 from the left, so that means as x is approaching 0 from the left, okay, the function values decrease without bound. Okay, so what that means here is that here we have our input values where we have negative 0.1, negative 0.01, negative 0.001, negative 0.0001. The outputs are getting smaller, smaller, and smaller. So what that means is as we're getting closer and closer to 0, the function is getting closer and closer to negative infinity. So as x is approaching 0 from the left, the function is approaching negative infinity. And that's how it's defined over here. So in arrow notation, as x approaches 0 from the left, the function is approaching negative infinity. Now, if you take a look at the input values approach 0 from the right-hand side. So let's say that now we are approaching 0 from the right side. Okay? And it's becoming very small. So if you notice here, we're going from 0.1, 0.01, 0.001, 0.0001. It's getting closer and closer to 0. So the direction is going towards 0. Okay? But if you look at the outputs, it's getting larger and larger and larger. So what that means is as x is approaching 0 from the right, okay, the output is getting larger and larger and larger. So that means that f of x is approaching positive infinity. And so you can see how it's written over here. Okay? So in figure 2, again, we are only looking at this scenario here. So again, as x is approaching 0 from the left, then the function is going towards negative infinity. And as x is approaching 0 from the right, it's approaching positive infinity. Okay, so what happens there? Well, what it does is that it creates a vertical line that it can never cross. And that vertical line has a specific name. Now, in this particular vertical line, it's passing through the value at x equals 0. Okay, so this behavior creates a vertical asymptote. And that's what we just created there, which is a vertical line that the graph approaches but never crosses. And in this case, the graph is approaching the vertical line x equals 0 as the inputs become close to 0. So as it comes close to 0 from the right, as it comes close to 0 from the left, okay, it's becoming a vertical asymptote. So you can see here, here's our vertical asymptote. So a vertical asymptote of a graph is a vertical line x equals a where the graph tends toward positive or negative infinity as the inputs approach a. And we write this as x is approaching a, the function approaches positive infinity. Or as x approaches the value of a, f of x approaches negative infinity.